Picture this, a future where humanity has unlocked the secrets of the cosmos, not through massive rockets or enormous spacecraft, but with technology so small it's invisible to the naked eye. What if tiny robots, no larger than a grain of sand, could construct entire space colonies on distant planets? Imagine a world where these microscopic marvels repair spacecraft in orbit, purify water from alien moons, and even transform barren landscapes into habitable worlds. This isn't science fiction, it's the future of space exploration powered by nanotechnology. In this video, we'll explore 30 mind-blowing predictions about how nanotechnology could revolutionize our journey to the stars. From self-healing materials to advanced life support systems, and from asteroid mining to interstellar communication, we'll uncover the incredible potential of these tiny yet transformative technologies. So, are you ready to dive into a future where the smallest tools make the biggest leaps? Let's embark on this journey together and discover how nanotechnology could shape the next chapter of human exploration in the universe. Now, let's zoom in on one of the most groundbreaking applications of nanotechnology in space exploration: nanobots for spacecraft repair. Imagine a scenario where a spacecraft traveling millions of miles from Earth suddenly sustains damage from micrometeoroids or mechanical wear. In the past, such issues could spell disaster, forcing missions to be aborted or leaving astronauts stranded. But with nanobots, this could become a thing of the past. These microscopic robots, no larger than a speck of dust, could be deployed to autonomously repair cracks, seal leaks, or replace damaged components, all while the spacecraft remains in orbit. How would this work? Nanobots could be made from advanced materials like carbon nanotubes or graphene, which are incredibly strong, lightweight, and resistant to extreme temperatures. Equipped with tiny sensors and tools, they could detect damage, analyze its extent, and carry out repairs with precision. For instance, they might use microscopic welding techniques to seal cracks or deposit new layers of material to reinforce weakened structures. This technology wouldn't just prevent mission failures, it could extend the lifespan of spacecraft, making long-term exploration missions far more feasible and cost-effective. The implications are staggering. Instead of depending on risky and expensive resupply missions or waiting for astronauts to perform manual repairs, spacecraft could essentially heal themselves, ensuring smooth and uninterrupted operations. This innovation could pave the way for missions to distant planets, asteroid belts, or even interstellar travel, where help from Earth is impossible. Nanobots for spacecraft repair represent a giant leap forward in our ability to explore the cosmos, proving that sometimes the smallest tools can solve the biggest challenges. And this is just the beginning. Next, we'll explore how nanotechnology could revolutionize the very materials our spacecraft are made of. Building on the incredible potential of nanobots for spacecraft repair, let's now turn our attention to another revolutionary idea: self-healing spacecraft materials. Picture a spacecraft's hull made from advanced nanomaterials that can detect and repair damage on their own, almost like living tissue. This isn't science fiction, it's a future that nanotechnology could make possible. Micrometeoroids, extreme temperatures, and radiation are just a few of the hazards spacecraft face in the harsh environment of space. Over time, these factors can cause cracks or structural weaknesses, jeopardizing the safety of missions and astronauts. But what if the materials themselves could respond to damage? Self-healing nanomaterials are designed to do just that. Embedded with tiny capsules of repair agents, these materials can automatically seal cracks or fill in gaps when damage occurs. Think of it as a spacecraft that can heal itself, much like how your skin repairs a cut. The science behind this is fascinating. For instance, some nanomaterials contain microcapsules filled with a liquid polymer that hardens when exposed to air or heat. When a crack forms, these capsules burst open, releasing the polymer to fill the gap and restore the material's integrity. other designs use heat or light to trigger a chemical reaction that bonds broken surfaces back together. These self-healing properties could dramatically reduce the need for manual repairs, saving time, money, and resources. The benefits are immense. Self-healing materials could make spacecraft more durable and reliable, especially for long-duration missions where maintenance isn't an option. They could also enhance safety by preventing small cracks from growing into catastrophic failures. Imagine a spacecraft on a mission to Mars, traveling through the void for months or years. With self-healing materials, it could endure the rigors of space without constant intervention, ensuring the mission stays on track. This innovation isn't just about improving spacecraft, it's about rethinking how we design for the challenges of space. By integrating self-healing materials, we could create vehicles that are not only stronger but also more adaptable, paving the way for safer and more ambitious explorations. And speaking of adapting, our next topic takes this idea even further, exploring how nanotechnology could transform life support systems for astronauts. Now, let's shift our focus to something equally groundbreaking: how nanotechnology could revolutionize life support systems for astronauts. Imagine being on a years-long journey through space, where every breath of air, every drop of water, and every bit of waste has to be carefully managed. It's a monumental challenge, but nanotechnology might just hold the key to making it easier and more sustainable. At the heart of this idea is efficiency. Life support systems in space need to recycle resources with minimal loss, and nanotechnology could take this to a whole new level. For air, nanosensors could continuously monitor oxygen levels and detect contaminants, ensuring astronauts always have clean, breathable air. Meanwhile, nanofilters could purify carbon dioxide, converting it back into oxygen with remarkable precision. This would not only reduce the need for resupply missions, but also make long-term space travel far more feasible. Water recycling is another area where nanotechnology could shine. Advanced nanomaterials could be used to create ultra-efficient filtration systems, capable of removing even the tiniest impurities from wastewater. Picture a system that can turn used water, whether from washing, drinking, or even urine, back into perfectly clean, drinkable water. This would drastically reduce the amount of water that needs to be transported from Earth, freeing up valuable space and resources for other mission-critical supplies. Waste management, often a daunting challenge in space, could also benefit from nanotechnology. Nanobots could break down organic waste into reusable components, converting it into fertilizer for space-grown plants or even raw materials for other processes. This closed-loop system would not only keep habitats cleaner but also contribute to a more sustainable ecosystem in space. It's like creating a miniature, self-sustaining environment that supports human life far from Earth. The implications of these advancements are enormous. By optimizing life support systems with nanotechnology, we could make long-term missions to Mars, the Moon, or even distant planets more viable. Astronauts would have reliable access to the essentials they need to survive and thrive, without the constant worry of running out of resources. And as we look to the stars, these innovations could be the foundation for establishing permanent human presence in space. With life support systems becoming more efficient, the next frontier lies in the very suits astronauts wear. Nanotechnology isn't just about systems, it's also about enhancing the tools and gear that make exploration possible. Let's explore how nano-enhanced spacesuits could change the game for astronauts in the harshest environments. As we look ahead, another exciting application of nanotechnology emerges: the development of next-generation spacesuits. These nano-enhanced suits could redefine what it means to explore the most unforgiving environments in space. Imagine a suit that's not just a barrier against the vacuum of space, but a high-tech marvel designed to enhance every movement and ensure maximum protection. Traditional spacesuits are bulky and restrictive, making even simple tasks challenging for astronauts. but with nanotechnology, we could create suits that are significantly lighter and more flexible. Advanced nanomaterials woven into the fabric of these suits could provide incredible strength without adding weight. This would allow astronauts to move more freely, whether they're repairing a spacecraft, collecting samples on a distant moon, or conducting experiments in zero gravity. Protection is another area where nanotechnology could make a huge difference. Space is filled with hazards, from extreme temperatures to micrometeoroids and harmful radiation. Nanomaterials could offer multi-layered defense, with self-healing properties to repair small punctures and thermal regulation to keep astronauts comfortable in both freezing cold and scorching heat. Additionally, nanosensors embedded in the suit could monitor the wearer's vitals in real time, alerting mission control to any potential health risks before they become serious. Perhaps one of the most groundbreaking features would be the integration of smart technology. Imagine a spacesuit that adjusts its insulation based on the surrounding temperature, or one that provides augmented reality overlays to guide astronauts through complex tasks. Nanotechnology could make these innovations possible, turning spacesuits into advanced tools that enhance productivity and safety. These nano-enhanced spacesuits could open up new possibilities for exploration. Astronauts could venture into more hazardous areas, stay outside their habitats for longer periods, and perform tasks with greater precision and ease. Whether it's walking on the surface of Mars or conducting repairs on the International Space Station, these suits would make every mission more efficient and less physically demanding. With such advancements in spacesuit technology, the next challenge lies in protecting astronauts from one of space's most persistent dangers, radiation. As we continue our journey into the cosmos, let's explore how nanotechnology could provide a solution to this critical issue. Shifting our focus to one of the most pressing challenges in space exploration, let's delve into how nanotechnology could revolutionize radiation shielding. Cosmic radiation poses a significant threat to astronauts, especially during long-duration missions beyond Earth's protective magnetic field. Without effective shielding, prolonged exposure to this radiation can lead to serious health risks, including cancer and damage to vital organs. This is where nanomaterials step in as a game-changer. Scientists are exploring the potential of advanced nanomaterials that can block or absorb harmful radiation more effectively than traditional shielding methods. These materials, such as boron nitride nanotubes and hydrogen-rich polymers, are not only lightweight but also highly efficient at neutralizing radiation particles. Their compact structure allows them to be integrated into spacecraft walls, spacesuits, and even habitats, providing robust protection without adding significant weight, a critical factor for space travel. One of the most promising applications is the development of layered shielding systems. By stacking different types of nanomaterials, each designed to block specific types of radiation, we can create a multi-layered defense that offers comprehensive protection. For instance, one layer might absorb high-energy protons while another deflects gamma rays. This approach ensures that astronauts are shielded from the full spectrum of cosmic radiation, making deep space missions safer and more feasible. Another innovative concept involves self-repairing nanomaterials that can automatically fix any damage caused by radiation exposure. This would significantly extend the lifespan of shielding systems, reducing the need for frequent repairs or replacements during missions. Additionally, nanosensors could be embedded within the shielding to monitor radiation levels in real time, providing astronauts and mission control with crucial data to adjust protocols as needed. The implications of these advancements are profound. With effective radiation shielding, we could extend the reach of human exploration to Mars, asteroids, and beyond. Astronauts could spend more time in deep space without compromising their health, paving the way for sustained missions and even the establishment of permanent colonies. As we continue to push the boundaries of space exploration, the next frontier lies in ensuring that our astronauts have access to sustainable resources. Let's explore how nanotechnology could transform food production in the vastness of space. Turning our attention to another critical aspect of space exploration, let's consider the challenge of sustaining life far from Earth. In the vast emptiness of space, providing astronauts with a reliable source of nutritious food is essential for long-term missions. Traditional methods of food production are bulky, resource-intensive, and impractical for confined environments like spacecraft or extraterrestrial habitats. This is where nanotechnology steps in, offering innovative solutions to revolutionize space agriculture. Nanotechnology could enable the creation of advanced systems for growing nutrient-rich food in small, controlled spaces. For instance, nanosensors could monitor soil conditions, moisture levels, and plant health in real time, ensuring optimal growth even in microgravity. These sensors would communicate with automated systems to adjust lighting, temperature, and nutrient delivery, creating a self-sustaining ecosystem that maximizes efficiency. One groundbreaking application is the development of nanoscale fertilizers and growth enhancers. These tiny particles could deliver nutrients directly to plant roots, reducing waste and accelerating growth. Unlike traditional fertilizers, which can be bulky and inefficient, nano-engineered alternatives would be lightweight, easy to transport, and highly effective even in limited quantities. Another exciting possibility is the use of nanomaterials to construct vertical farming systems. These structures would be incredibly compact yet capable of producing large quantities of food. By layering crops in a three-dimensional grid and using nanotechnology to optimize each layer, we could grow a variety of fruits, vegetables, and grains in a fraction of the space required on Earth. Nanotechnology could also play a role in preserving and recycling resources essential for agriculture. For example, nanosystems could purify water from extraterrestrial sources, making it safe for irrigation. Additionally, waste products could be broken down at the molecular level and converted into usable nutrients, creating a closed-loop system that minimizes reliance on external supplies. The implications of nano-engineered food production are immense. Not only would it ensure that astronauts have access to fresh, healthy meals during long missions, but it could also support the establishment of permanent colonies on other planets. By making space agriculture efficient and sustainable, nanotechnology would help humanity take its next giant leap into the cosmos. As we look ahead, the challenges of exploring and inhabiting space go beyond just food and resources. Let's explore how nanotechnology could transform the very environments we seek to inhabit, starting with the ambitious concept of terraforming. Now, let's venture into one of the most fascinating and ambitious applications of nanotechnology in space exploration: terraforming. Imagine transforming barren, lifeless environments into thriving ecosystems capable of supporting human life. While this concept might sound like science fiction, nanotechnology could play a pivotal role in turning this dream into reality. One of the biggest challenges in terraforming is altering the atmospheric composition of a planet. Nanomaterials could be designed to capture and convert harmful gases such as carbon dioxide into oxygen. For example, nanoscale catalysts could accelerate the breakdown of toxic compounds, gradually making the air breathable. These tiny particles could be dispersed across a planet's surface, working tirelessly to create a stable and habitable atmosphere. Another critical aspect is modifying soil conditions to support agriculture. Nanotechnology could introduce microscopic agents into the soil to enhance its fertility. These agents could break down rocky, nutrient-poor substrates and release essential minerals, creating a foundation for plant growth. Over time, this process could transform vast, barren landscapes into fertile grounds capable of sustaining crops and ultimately human colonies. Water, a vital resource for life, is another area where nanomaterials could make a difference. nanosystems could extract water from underground ice or atmospheric moisture, purifying it for human use. Additionally, they could distribute water evenly across the planet's surface, ensuring that every region has access to this essential resource. The integration of nanotechnology into terraforming efforts would also enable real-time monitoring and adjustment of environmental conditions. Networks of nanosensors could track temperature, humidity, and other factors, providing data to optimize the terraforming process. This feedback loop would ensure that changes occur at the right pace and scale, avoiding unintended consequences. While terraforming remains a long-term goal, the potential of nanotechnology to address its challenges is undeniable. By harnessing the power of these tiny yet powerful tools, we could one day transform inhospitable worlds into new homes for humanity. This vision not only pushes the boundaries of what's possible, but also underscores the importance of innovation in our quest to explore and inhabit the cosmos. As we consider the possibilities of terraforming, it's worth turning our attention to another pressing issue in space: the growing problem of debris in Earth's orbit and beyond. As we shift our focus from the vast potential of terraforming to a more immediate concern, we encounter the growing problem of space debris. Orbiting Earth at incredible speeds, these fragments of old satellites, rocket parts, and other discarded materials pose a significant threat to active spacecraft and satellites. But what if nanotechnology could offer a solution to this escalating issue? One promising approach involves the use of nanobots designed to locate, capture, and deorbit space debris. These tiny robots could be programmed to identify specific pieces of debris, approach them safely, and attach themselves to the fragments. Once secured, the nanobots could either guide the debris into a controlled re-entry, where it would burn up harmlessly in the Earth's atmosphere, or redirect it to specialized collection points for recycling. Nanotechnology could also enable the development of advanced materials capable of capturing debris passively. For instance, nanosatellites equipped with lightweight, nanomaterial-based nets or adhesive surfaces could be deployed to collect smaller fragments. These systems would operate autonomously, minimizing human intervention and significantly reducing the time and cost associated with debris removal. Another innovative idea involves using nanosensors to track debris in real time. Networks of these sensors could provide precise data on the location, speed, and trajectory of debris, enabling more effective cleanup strategies. This information would be invaluable for coordinating nanobot missions and avoiding collisions during cleanup operations. The benefits of such technologies extend beyond debris removal. By keeping orbital pathways clear, nanotechnology could enhance the safety and longevity of satellites, space stations, and future missions. It could also reduce the risk of cascading collisions, known as the Kessler syndrome, where one collision generates more debris, leading to further collisions in a dangerous chain reaction. While the challenge of space debris is immense, the potential of nanotechnology to address it is equally compelling. By leveraging the precision and efficiency of nanobots and nanosystems, we could turn the tide on this growing problem, ensuring that space remains accessible and safe for exploration and innovation. With the issue of space debris in mind, let's explore how nanotechnology could revolutionize another critical aspect of space travel: propulsion systems. Now, let's turn our attention to how nanotechnology could transform the way we propel spacecraft through the cosmos. Traditional propulsion systems often rely on heavy fuel loads and complex machinery, which can limit efficiency and increase costs. However, the integration of nanomaterials could revolutionize this critical aspect of space travel, opening the door to faster, more efficient journeys across the stars. One of the most exciting possibilities lies in the development of nanomaterial-based fuels. These advanced fuels could offer higher energy densities, meaning spacecraft could travel farther using less fuel. Imagine a scenario where spacecraft are powered by lightweight, nanotech-enhanced fuel cells that store more energy in a smaller space. This would not only reduce the weight of the spacecraft but also extend mission ranges, making deep space exploration more feasible. Nanotechnology could also improve the design of propulsion engines themselves. By incorporating nanomaterials into engine components, we could create systems that operate at higher temperatures and pressures without degrading. This would allow for more powerful thrust while maintaining durability, a crucial factor for long-duration missions. Additionally, nanosensors embedded within engines could monitor performance in real time, detecting issues before they become critical and optimizing efficiency on the fly. Another groundbreaking application involves the use of nanobots for in-space refueling. These tiny robots could repair or replace engine components mid-flight, or even extract and refine fuel from extraterrestrial sources like asteroids or moons. This capability would reduce the need for spacecraft to carry all their fuel from Earth, significantly lowering launch costs and enabling more sustainable exploration. Beyond traditional chemical propulsion, nanotechnology could also advance alternative methods like ion or plasma-based systems. Nanomaterials could enhance the efficiency of these systems by improving the generation and containment of charged particles, leading to faster acceleration and reduced energy consumption. Such advancements could pave the way for interstellar travel where speed and efficiency are paramount. By enhancing fuel efficiency, engine performance, and propulsion technologies, nanotechnology could make space travel not only faster and more cost-effective but also more sustainable. These innovations could bring us closer to exploring distant worlds and unlocking the mysteries of the universe. As we consider how nanotechnology could revolutionize propulsion, let's explore its potential to transform another vital aspect of space exploration: resource extraction. Shifting our focus to the realm of resource extraction, nanotechnology holds immense potential for space mining, a critical step in sustaining future space colonies. Imagine a future where nanobots are deployed to asteroids or moons, tirelessly extracting valuable resources like metals, water, and rare minerals. These tiny machines could perform tasks far beyond the capabilities of traditional mining equipment, operating in extreme environments with precision and efficiency. One of the most significant advantages of nanotechnology in space mining is its ability to miniaturize the extraction process. Instead of relying on bulky, energy-intensive machinery, nanobots could use advanced tools on a microscopic scale to break down rock and collect valuable materials. This would drastically reduce the cost and complexity of mining operations, making it feasible to harvest resources from distant celestial bodies. Another groundbreaking application involves the use of self-replicating nanobots. These machines could use the materials they extract to build more nanobots, exponentially increasing the scale of mining operations without requiring additional equipment from Earth. This self-sustaining approach would not only enhance efficiency but also reduce the need for frequent resupply missions, a major hurdle in deep space exploration. Nanotechnology could also enable real-time analysis of extracted materials. Equipped with nanosensors, these bots could identify and separate valuable resources on the spot, ensuring that only the most useful materials are transported back to space colonies or spacecraft. This capability would streamline the mining process, minimizing waste and maximizing productivity. Beyond extraction, nanotechnology could play a crucial role in processing these materials. For instance, nanobots could refine metals or extract water directly at the mining site, turning raw materials into usable resources without the need for extensive infrastructure. This would support the development of in-space manufacturing, allowing colonies to produce tools, equipment, and even habitats using locally sourced materials. By leveraging nanotechnology for space mining, we could significantly reduce our reliance on Earth's resources, paving the way for self-sustaining space colonies. These innovations could transform the way we approach resource extraction, making it a cornerstone of humanity's future in space. With the potential of space mining explored, let's delve into how nanotechnology could revolutionize the construction of habitats in space. Turning our attention to the construction of space habitats, nanotechnology offers groundbreaking possibilities for creating structures that are not only lightweight and durable, but also capable of sustaining life in the harshest environments. Imagine habitats built from nanomaterials that can adapt to extreme temperatures, resist radiation, and even repair themselves when damaged. These innovations could transform how we live and work in space, making long-term colonization a reality. One of the most exciting applications is the use of nanomaterials to build habitats that are incredibly lightweight yet exceptionally strong. Traditional construction materials are heavy and difficult to transport, but nanomaterials like carbon nanotubes or graphene could provide the same strength at a fraction of the weight. This would make it easier to transport building materials to space or even manufacture them on site using locally sourced resources. Nanotechnology could also enable habitats to be self-sustaining. For instance, nanoscale coatings could be applied to surfaces to harvest solar energy or convert carbon dioxide into oxygen, reducing the need for external life support systems. These smart materials could regulate temperature, purify water, and even generate electricity, creating a fully functional ecosystem within the habitat. Another revolutionary concept is the use of self-healing nanomaterials. In the unforgiving environment of space, even minor damage to a habitat could pose significant risks. Nanomaterials embedded with self-repairing properties could automatically seal cracks or breaches, ensuring the safety of occupants without requiring constant maintenance. This would be particularly vital for habitats on distant planets, where repair missions from Earth would be impractical. Nanotechnology could also enable modular construction, where habitats are assembled from prefabricated nanosheets or nanocubes. These modules could be easily transported and assembled in space, allowing for rapid construction of large-scale habitats. The flexibility of nanomaterials would also allow habitats to be expanded or reconfigured as needed, adapting to the changing needs of a growing colony. By leveraging nanotechnology in the construction of space habitats, we could create structures that are not only functional but also resilient and adaptable. These advancements would lay the foundation for sustainable living in space, bringing us one step closer to becoming a multi-planetary species. As we envision these futuristic habitats, let's explore how nanotechnology could enhance environmental monitoring in space, ensuring the safety and comfort of those who call these habitats home. Moving forward, let's dive into how nanotechnology could revolutionize environmental monitoring in space habitats. Picture a network of tiny, highly sensitive nanosensors embedded throughout the structure, constantly keeping an eye on air quality, temperature, humidity, and even radiation levels. These sensors could provide real-time data, ensuring that living conditions remain safe and comfortable for astronauts. One of the most critical roles of these nanosensors would be monitoring air quality. In the confined environment of a space habitat, maintaining breathable air is essential. Nanosensors could detect trace amounts of harmful gases such as carbon monoxide or methane and alert systems to filter or neutralize them before they pose a risk. This would be a game changer for long-term missions, where even small fluctuations in air composition could have serious consequences. Temperature regulation is another area where nanosensors could shine. Space habitats face extreme temperature fluctuations, from the freezing cold of shadowed areas to the intense heat of direct sunlight. Nanosensors could continuously monitor temperature variations and work in tandem with smart materials to adjust heating or cooling systems automatically. This would ensure a stable and comfortable environment for inhabitants, even in the most challenging conditions. Humidity control is equally important, especially in closed-loop life support systems. Too much moisture can lead to mold or equipment corrosion, while too little can cause discomfort and health issues. Nanosensors could measure humidity levels and trigger systems to add or remove moisture as needed, maintaining an ideal balance. Radiation monitoring is perhaps one of the most vital functions of nanosensors in space. Cosmic radiation poses a significant threat to human health, and prolonged exposure can increase the risk of cancer and other illnesses. Nanosensors could detect incoming radiation and activate shielding mechanisms or alert astronauts to take protective measures. This would be particularly crucial for habitats on the Moon, Mars, or deep space missions where Earth's protective magnetosphere is absent. Beyond safety, these nanosensors could also enhance comfort by optimizing lighting and noise levels. Adjusting light intensity based on circadian rhythms or reducing noise pollution could significantly improve the quality of life for space travelers. By integrating nanotechnology into environmental monitoring, we could create habitats that are not only safe but also tailored to the needs of their inhabitants, making space living more sustainable and enjoyable. Now, let's shift our focus to how nanotechnology could transform medical care in space, ensuring the health and well-being of astronauts on long-duration missions. Now, let's turn our attention to how nanotechnology could revolutionize medical care in space, ensuring astronauts stay healthy during long-duration missions. Imagine tiny nanobots coursing through the bloodstream, delivering medications precisely where they're needed or even repairing damaged tissues at a cellular level. This could be a game changer for space travel, where access to medical facilities and resources is extremely limited. One of the most promising applications is targeted drug delivery. Traditional medications often affect the entire body, sometimes causing unwanted side effects. With nanotechnology, drugs could be encapsulated in nanoparticles designed to release their contents only in specific areas, such as a tumor or an injured organ. This precision not only increases the effectiveness of treatments but also minimizes risks, a critical advantage when medical help is millions of miles away. Another groundbreaking possibility is real-time health monitoring. Nanosensors implanted in the body could continuously track vital signs like heart rate, blood pressure, and oxygen levels. These sensors could send data to a central system, alerting astronauts and mission control to any abnormalities before they escalate into serious issues. For example, if a sensor detects early signs of dehydration or radiation exposure, it could prompt immediate action, potentially saving lives. Nanotechnology could also play a role in treating emergencies. Imagine a nanobot swarm that could quickly stop internal bleeding or repair a damaged organ, acting as a first responder in critical situations. These capabilities could significantly reduce the risks associated with long-term space missions, where traditional medical interventions might not be feasible. Beyond physical health, nanotechnology could address mental well-being. Nanosensors could monitor stress hormones and other biomarkers, helping to identify when an astronaut might need psychological support. This could be invaluable for maintaining mental health during the isolation and pressures of space travel. By integrating nanotechnology into medical care, we could create a safety net that ensures astronauts remain healthy and resilient, no matter how far they venture from Earth. These advancements wouldn't just protect space travelers, they could also lead to breakthroughs in medicine here on our planet. Next, let's explore how nanotechnology could improve energy storage solutions, powering space missions more efficiently and reliably. Turning our gaze to the next frontier, let's delve into how nanotechnology could transform energy storage, a critical component of any space mission. Imagine lightweight, high-capacity batteries that not only last longer but also charge faster, all thanks to the ingenuity of nanomaterials. In the vastness of space, where every ounce of weight and every joule of energy counts, this innovation could redefine the efficiency of spacecraft and habitats. One of the most exciting possibilities lies in the development of nanomaterial-enhanced batteries. Traditional batteries, while effective, are often bulky and have limited energy densities. Enter nanotechnology. By incorporating materials like carbon nanotubes or graphene into battery design, we could create cells that store more energy while being significantly smaller and lighter. This means spacecraft could carry more power without the added weight, extending mission durations and enabling more ambitious explorations. Another breakthrough could be in the realm of rapid charging. Nanomaterials have unique properties that allow for faster ion transport, which translates to quicker recharge times. For astronauts on the go, this could mean less downtime waiting for equipment to power up and more time focused on their mission objectives. But it doesn't stop there. Nanotechnology could also improve the durability of energy storage systems. Space is a harsh environment with extreme temperatures and radiation that can degrade conventional batteries. Nanomaterials, with their enhanced resilience, could withstand these conditions, ensuring reliable power even in the most challenging circumstances. Moreover, these advancements aren't just confined to space. The same technologies could revolutionize energy storage here on Earth, powering everything from electric vehicles to renewable energy grids. By pushing the boundaries of what's possible in space, we're also paving the way for a more sustainable future on our home planet. As we've seen, nanotechnology holds immense potential for reshaping energy storage in space exploration. From lighter, more efficient batteries to systems that endure the rigors of space, these innovations could power the next generation of missions beyond our world. Now, let's shift our focus to how nanotechnology could enhance communication systems, enabling faster and more reliable data transmission across the cosmos. Now, let's explore how nanotechnology could revolutionize the way we communicate across the vastness of space. In an era where missions are venturing farther than ever before, ensuring fast and reliable data transmission is crucial. Nanotechnology offers innovative solutions that could redefine space communication, making it more efficient and resilient. One of the key advancements could come in the form of nano-enhanced antennas. Traditional communication systems often rely on large, bulky equipment to transmit signals over long distances. However, nanomaterials like graphene and carbon nanotubes could be used to create antennas that are not only smaller but also more powerful. These nano-antennas could transmit data with greater precision and over longer ranges, ensuring that messages from distant spacecraft reach Earth without delay. Another exciting possibility is the development of quantum communication systems enabled by nanotechnology. Quantum dots, which are nanoscale semiconductor particles, could be used to encode and transmit information with unprecedented security and speed. This could be a game changer for sensitive communications, protecting data from interception or interference during long-distance transmissions. Additionally, nanotechnology could improve the reliability of communication networks in space. Space is filled with hazards like radiation and micrometeoroids, which can disrupt signals and damage equipment. Nanomaterials, with their enhanced durability, could be used to create communication systems that are more resistant to these challenges, ensuring uninterrupted connections even in the harshest conditions. Moreover, nanotechnology could play a role in reducing the energy consumption of communication systems. By using nanomaterials that require less power to operate, we could extend the lifespan of spacecraft and reduce the need for frequent maintenance or resupply missions. These advancements wouldn't just benefit space exploration, they could also have applications here on Earth, from improving satellite communications to enhancing global internet connectivity. The impact of nano-enhanced communication systems could be far-reaching. As we continue to push the boundaries of space exploration, nanotechnology promises to keep us connected, no matter how far we venture. With faster, more reliable communication systems, the cosmos becomes a little more accessible and our missions a little more achievable. Now, let's shift our focus to another transformative application of nanotechnology: its potential to enable advanced space manufacturing, allowing us to build complex structures and tools directly in space. Moving forward, let's delve into how nanotechnology could transform the way we manufacture in space. One of the biggest challenges of space exploration is the cost and complexity of transporting materials from Earth. Nanobots working at the molecular level could change the game entirely by enabling the assembly of complex structures directly in space. Imagine tiny robots invisible to the naked eye, capable of building everything from spacecraft components to habitats on distant planets. These nanobots could use raw materials harvested from asteroids or moons, eliminating the need to carry heavy payloads from Earth. This would not only reduce launch costs but also make long-term missions more sustainable. For example, nanobots could construct solar panels, communication arrays, or even entire space stations piece by piece. By operating in microgravity, they could achieve precision and efficiency that's impossible on Earth. These nanoscale builders could work tirelessly, assembling structures atom by atom, ensuring that every component is perfectly designed for the harsh conditions of space. Another exciting application is the creation of tools and spare parts on demand. Instead of waiting months for a replacement part to arrive from Earth, astronauts could simply program nanobots to manufacture what they need in real time. This would drastically reduce mission delays and improve safety, as crews would always have access to critical equipment. Moreover, nanotechnology could enable the development of entirely new materials tailored for space. By manipulating matter at the atomic level, scientists could create lightweight yet incredibly strong materials that are resistant to radiation, extreme temperatures, and micrometeoroid impacts. These advancements would revolutionize the way we design and build for space exploration. The implications of space manufacturing with nanotechnology are immense. It could pave the way for large-scale infrastructure projects on the Moon, Mars, or even in orbit, making the dream of space colonization a tangible reality. As we continue to push the boundaries of what's possible, nanobots could become the ultimate architects of our extraterrestrial future. Next, let's turn our attention to how nanotechnology could enhance the capabilities of robots designed for space exploration, opening up new frontiers in discovery and innovation. Now, let's shift our focus to how nanotechnology could revolutionize the robots we send to explore the far reaches of our solar system and beyond. Space exploration robots like rovers and probes are already invaluable tools for gathering data and conducting experiments in environments too hostile for humans. But with nanotechnology, these machines could become even more advanced, adaptive, and capable of tackling the unknown. Picture a robot equipped with nanoscale sensors, so sensitive they can detect the faintest traces of water or organic compounds on a distant moon. These sensors, powered by nanotechnology, could analyze soil, atmosphere, and even microscopic particles with unprecedented accuracy. This would allow robots to identify potential signs of life or resources that could support future missions. Nanotechnology could also give these robots the ability to self-repair. Just like spacecraft, exploration robots are exposed to extreme conditions that can cause wear and tear. Imagine a rover on Mars damaged by a dust storm, automatically repairing its own components using nanobots embedded in its structure. This would extend the lifespan of missions and reduce the risk of losing valuable equipment. Another exciting possibility is the use of nanomaterials to make robots lighter, stronger, and more energy efficient. By incorporating these materials, robots could carry more scientific instruments or travel greater distances without needing frequent recharging. This would open up new opportunities to explore areas that were previously out of reach. Nanotechnology could even enable robots to adapt to their environments in real time. For instance, a robot exploring the icy surface of Europa could use nanoscale mechanisms to alter its shape or movement, allowing it to navigate cracks, crevices, or uneven terrain with ease. Such adaptability would make these machines incredibly versatile, capable of handling a wide range of challenges. Finally, consider the potential for nanobots to work alongside exploration robots. These tiny assistants could perform tasks like collecting samples, analyzing materials, or even constructing small structures on the surface of a planet. Together, robots and nanobots could form a highly efficient team, pushing the boundaries of what we can discover in space. As we look to the future, nanotechnology could transform space exploration robots into smarter, more resilient, and more capable explorers, unlocking the secrets of distant worlds like never before. Next, we'll explore how nanotechnology could play a crucial role in managing heat in the extreme environments of space, ensuring the safety and efficiency of both machines and humans. Now, let's turn our attention to one of the most critical challenges in space exploration: managing heat. Whether it's the scorching temperatures near the sun or the freezing cold of distant moons, extreme conditions can pose serious risks to both equipment and astronauts. Nanotechnology, however, could provide innovative solutions to regulate temperatures and ensure safety in these harsh environments. One of the most promising applications is the development of nanomaterials with exceptional thermal properties. These materials could be designed to absorb, reflect, or dissipate heat as needed, acting like a high-tech thermostat for spacecraft and habitats. For instance, a spaceship traveling close to the sun could use nanomaterial coatings to reflect excess heat, preventing critical systems from overheating. Conversely, on a frigid moon like Europa, the same materials could trap and retain heat, keeping the interior of a habitat warm and habitable. Nanotechnology could also enable adaptive thermal regulation. Imagine a spacecraft equipped with nanoscale sensors that constantly monitor temperature fluctuations. If the sensors detect a rise in heat, they could trigger the release of cooling nanomaterials or adjust the material properties to dissipate the excess energy. This real-time responsiveness would help maintain stable conditions, even in unpredictable environments. Another exciting possibility is the use of nanomaterials to create lightweight insulation. Traditional insulation often adds significant weight to spacecraft, limiting their efficiency and range. Nanomaterials, however, could offer superior insulation in a much thinner and lighter form. This would not only reduce the overall mass of the spacecraft, but also free up space for additional scientific instruments or resources. Nanotechnology could even play a role in personal temperature regulation for astronauts. Spacesuits embedded with nanomaterials could adjust to the wearer's body temperature, keeping them comfortable during spacewalks in extreme conditions. This would enhance safety and allow astronauts to focus on their tasks without worrying about overheating or freezing. By integrating nanotechnology into heat management systems, we could protect both humans and machines from the extreme temperatures of space, ensuring missions are safer, more efficient, and more successful. Next, we'll explore how nanotechnology could revolutionize another essential aspect of space exploration: water purification, ensuring astronauts have access to clean, safe water on distant planets and moons. Turning to another vital aspect of survival in space, let's dive into how nanotechnology could transform water purification. Access to clean, safe water is essential for any long-term mission or colony, and extraterrestrial environments present unique challenges. Nanotechnology offers innovative solutions to tackle these hurdles, ensuring astronauts have a reliable supply of drinkable water even on distant planets or moons. One of the most promising applications is the use of nanoscale filters. These filters, made from advanced nanomaterials, could remove even the tiniest contaminants from water, including harmful bacteria, viruses, and toxic chemicals. Unlike traditional filtration systems, which can be bulky and inefficient, nanofilters are incredibly compact and highly effective. This makes them ideal for space missions where every ounce of weight and inch of space matters. Nanotechnology could also enable the development of self-cleaning filtration systems. Over time, traditional filters can become clogged with debris, reducing their effectiveness. However, nanomaterial coatings could prevent this by repelling contaminants or breaking them down at the molecular level. This would extend the lifespan of the filtration system and reduce maintenance needs, a crucial advantage in remote locations far from Earth. Another exciting possibility is the use of nanomaterials to extract water from extraterrestrial sources. For example, on Mars, where water exists in the form of ice or briny liquids, nanotechnology could be used to extract and purify it. Nanosensors could detect water deposits, while nanobots or specialized materials could extract and process it, making it safe for consumption. Nanotechnology could also enhance water recycling systems in space habitats. Currently, systems like those on the International Space Station recycle urine and other wastewater, but nanotech could make these processes even more efficient. Advanced nanomaterials could break down impurities more effectively, ensuring that every drop of water is reused to its full potential. By integrating nanotechnology into water purification systems, we could ensure that astronauts on long-term missions or colonies have access to clean, safe water, regardless of where they are in the solar system. Next, we'll explore how nanomaterials could revolutionize energy generation in space, paving the way for more sustainable and powerful missions. Shifting our focus to energy, let's explore how nanotechnology could unlock the potential of space-based solar power. As humanity looks to establish colonies and conduct long-term missions in space, finding reliable and efficient energy sources becomes critical. Traditional solar panels, while effective, have limitations that nanotechnology could overcome, making large-scale energy generation in space not just feasible but highly efficient. One of the most significant advancements could come from nanomaterials that enhance the light-absorbing capabilities of solar panels. By incorporating nanostructures like quantum dots or nanowires, solar panels could capture a broader range of the light spectrum, including wavelengths that conventional panels miss. This would significantly boost their energy output, making them far more effective in the dimmer light conditions of deep space or on planets farther from the Sun. Nanotechnology could also address one of the biggest challenges of space-based solar panels: durability. In the harsh environment of space, solar panels are exposed to extreme temperatures, radiation, and micrometeoroid impact. Nanomaterials, with their exceptional strength and resistance to degradation, could create panels that are not only more durable but also lighter and easier to transport. This would reduce launch costs and increase the viability of deploying solar arrays on a large scale. Another exciting possibility is the development of self-repairing solar panels using nanotechnology. Imagine panels that can autonomously detect and fix micro cracks or damage caused by space debris. Nanobots or specialized coatings could patch up these issues in real time, ensuring consistent performance over long periods without human intervention. Nanotechnology could also enable the creation of flexible, rollable solar panels. Traditional panels are rigid and bulky, making them difficult to deploy in space. But with nanomaterials, we could design panels that are thin, lightweight, and easy to unfurl, allowing for larger installations that can be compactly stored during launch. This innovation would make it possible to generate massive amounts of energy to power space habitats, spacecraft, or even entire colonies. By harnessing the power of nanotechnology, space-based solar power could become a cornerstone of sustainable energy in the cosmos. Up next, we'll delve into how nanotechnology could revolutionize navigation systems, making space travel more precise and reliable than ever before. Turning our attention to navigation, the role of nanotechnology could be a game-changer in guiding spacecraft through the vast and unpredictable expanse of space. Precision in navigation is crucial for ensuring that missions reach their destinations safely and efficiently. And here, nanotechnology holds the key to unlocking unprecedented levels of accuracy. One of the most promising applications lies in the development of nanosensors. These tiny devices, capable of detecting even the slightest changes in a spacecraft's position or trajectory, could provide real-time data to onboard navigation systems. By continuously monitoring factors like velocity, orientation, and gravitational forces, nanosensors would allow spacecraft to make minute adjustments on the fly, ensuring they stay on course even in the most challenging conditions. Nanotechnology could also revolutionize the way spacecraft process navigation data. Traditional systems rely on bulky and energy-intensive computers, but nanoscale processors could offer the same computational power in a fraction of the size and weight. This would not only reduce the overall mass of the spacecraft, but also free up valuable space and resources for other critical systems. Another exciting possibility is the use of nanomaterials to create ultra-precise gyroscopes and accelerometers. These devices, essential for measuring movement and orientation, could be made smaller, lighter, and more sensitive with nanotechnology. Enhanced gyroscopes would allow spacecraft to maintain stability and accuracy even during long journeys, reducing the risk of drift or miscalculations. Additionally, nanotechnology could enable the development of advanced star tracking systems. By incorporating nanostructured lenses or detectors, these systems could capture and analyze starlight with incredible precision, helping spacecraft determine their position relative to celestial bodies. This would be especially useful in deep space, where traditional navigation methods like GPS become ineffective. By integrating nanotechnology into navigation systems, we could make space travel not only more accurate but also more reliable and efficient. As we look ahead, the next frontier explores how nanotechnology could transform space tourism, making it safer and more accessible for everyday adventurers. Now, let's shift our focus to the exciting world of space tourism and how nanotechnology could play a pivotal role in making it a reality for more people. Imagine stepping onto a spacecraft knowing that the journey ahead is not only thrilling but also incredibly safe and comfortable, thanks to the advancements in nanoscale technologies. One of the most significant contributions of nanotechnology to space tourism lies in enhancing safety. Nanomaterials could be used to construct spacecraft that are lighter yet stronger, offering better resistance to the extreme conditions of space. For instance, nanosensors embedded throughout the vehicle could continuously monitor structural integrity, detecting potential issues like stress fractures or material fatigue long before they become a problem. This real-time monitoring system would allow for immediate repairs or adjustments, ensuring passengers are always in safe hands. Comfort is another area where nanotechnology could make a huge difference. Imagine the interior of a spacecraft fitted with nanoscale climate control systems, maintaining the perfect temperature and humidity levels for passengers. Nanofibers could be woven into seats and fabrics, making them more breathable, durable, and even capable of adapting to the body's needs for maximum comfort during long journeys. Nanotechnology could also revolutionize the way tourists experience space. For example, nano-enhanced windows could provide clearer and more vivid views of the cosmos, free from distortions or glare. These windows could even incorporate smart coatings to filter harmful radiation or adjust tint levels automatically, ensuring passengers enjoy the breathtaking sights without compromising their safety. Accessibility is another key factor, and here nanotechnology could help reduce costs by making spacecraft more efficient and sustainable. Nano-engineered propulsion systems could use less fuel while delivering higher performance, lowering the overall expense of space travel. Additionally, nanobots could assist in recycling resources on board, such as air and water, making long-term missions feasible and reducing the need for frequent resupply trips. From safety to comfort and affordability, nanotechnology has the potential to transform space tourism from a rare luxury into an achievable dream for many. As we continue to explore the cosmos, these advancements could open the door for more people to experience the wonders of space. Next, let's dive into how nanotechnology could redefine the way we conduct research in the unique environment of space. Turning our attention to the realm of space research, nanotechnology promises to unlock a new era of precision and efficiency in scientific experiments conducted in microgravity environments. The unique conditions of space allow for discoveries that are impossible on Earth, and nanotechnology could amplify these opportunities by providing tools and systems that are both highly sensitive and incredibly compact. In microgravity, even the smallest variables can have significant impacts on experiments. Nanosensors, tiny but powerful, could monitor these variables with unparalleled accuracy. For instance, they could track changes in temperature, pressure, or chemical reactions at the molecular level, providing researchers with detailed data that could lead to groundbreaking insights. These nanosensors could be integrated into experimental setups, ensuring that every detail is captured and analyzed in real time. Another exciting application is the use of nanorobots to conduct experiments autonomously. These tiny machines could manipulate samples or materials at scales far too small for human hands, enabling experiments that require extreme precision. Imagine nanorobots assembling complex molecular structures or delivering precise doses of chemicals in microgravity, all while researchers monitor and control the process remotely. Nanotechnology could also improve the efficiency of experiments by minimizing resource usage. Nano-engineered materials could reduce the size and weight of experimental equipment, making it easier to transport to space. Additionally, nanoscale systems could recycle or reuse materials during experiments, ensuring that limited resources are maximized. This would be particularly valuable for long-term research missions where resupply is not an option. The potential for collaboration between nanotechnology and space research is vast, from enhancing the accuracy of data collection to enabling entirely new types of experiments. These advancements could accelerate our understanding of science in ways we've only begun to imagine. As we continue to explore the cosmos, nanotechnology will undoubtedly play a crucial role in unlocking its mysteries. Next, let's examine how nanomaterials could be used to build essential infrastructure for future space colonies. As we look toward the future of space colonization, the role of nanotechnology in constructing essential infrastructure becomes increasingly vital. Imagine arriving on another planet and needing to build roads, tunnels, and shelters from scratch. Nanomaterials could be the key to making this process faster, more efficient, and sustainable. One of the most promising applications is the use of self-assembling nanomaterials. These materials could be programmed to form specific structures, such as roads or tunnels, with minimal human intervention. For instance, nanobots could be deployed to gather local resources like regolith from the Moon or Mars and process them into durable building materials. This would significantly reduce the need to transport heavy construction equipment from Earth, saving both time and resources. Another exciting possibility is the development of lightweight yet incredibly strong nanomaterials. These could be used to create infrastructure that can withstand the harsh conditions of other planets, such as extreme temperatures, radiation, and micrometeoroid impacts. For example, nano-engineered composites could be used to build roads that are resistant to cracking or tunnels that remain stable even in unstable terrain. Nanotechnology could also enhance the sustainability of space colonies. Self-healing materials, for instance, could repair cracks or damage in infrastructure over time, reducing the need for maintenance. Additionally, nanomaterials could be designed to recycle waste products into new building materials, creating a circular economy that minimizes resource consumption. The potential for nanotechnology in space colony infrastructure is truly transformative. From self-assembling roads to durable, self-healing tunnels, these advancements could make the dream of establishing permanent human settlements on other planets a reality. As we continue to push the boundaries of exploration, nanotechnology will be at the forefront, enabling us to build a future among the stars. Now, let's turn our attention to how nanotechnology could revolutionize waste management in space habitats, ensuring sustainability for long-term missions. Moving ahead, let's explore how nanotechnology could tackle one of the most pressing challenges of long-term space habitation: waste management. In the confined environments of space habitats, managing waste efficiently is crucial for maintaining cleanliness, health, and sustainability. Here's where nanotechnology steps in with innovative solutions that could transform how we handle waste beyond Earth. One of the key applications lies in the development of nanobots designed to break down waste products at the molecular level. These tiny machines could process organic and inorganic waste, turning it into reusable materials. For instance, food waste could be decomposed into nutrients for hydroponic systems, while plastic waste could be converted into raw materials for 3D printing or construction. This would not only reduce the volume of waste, but also create a closed-loop system that minimizes reliance on Earth for supplies. Another exciting possibility is the use of nanocatalysts to accelerate chemical reactions that decompose waste. These catalysts could be embedded in filtration systems or waste treatment units, ensuring that harmful substances are neutralized quickly and efficiently. This would be particularly important for managing toxic waste or byproducts from scientific experiments, keeping the habitat safe for its inhabitants. Nanotechnology could also introduce self-cleaning surfaces within space habitats. By coating walls, floors, and equipment with nano-engineered materials, we could prevent the buildup of bacteria, mold, and debris. These surfaces could repel contaminants or break them down when exposed to light or air, maintaining a hygienic environment with minimal effort from the crew. Additionally, nanomaterials could play a role in recycling water and air. Advanced filtration systems using nano-enhanced membranes could remove pollutants and pathogens, ensuring that water and air are continuously purified and reused. This would drastically reduce the need for resupply missions, making space habitats more self-sufficient and sustainable. The integration of nanotechnology into waste management systems could revolutionize how we live and work in space. By turning waste into resources, ensuring cleanliness, and reducing dependency on Earth, these advancements would pave the way for longer, healthier, and more sustainable missions. Now, let's shift our focus to how nanotechnology could help us predict and prepare for space weather events, protecting both astronauts and equipment from the dangers of the cosmos. Turning our attention to the skies above, let's delve into how nanotechnology could safeguard us from the unpredictable forces of space weather. Solar flares and cosmic radiation pose significant risks to both astronauts and equipment, making early detection and prediction essential for mission success. Enter nanosensors, tiny yet powerful tools that could revolutionize how we monitor and respond to these cosmic threats. Imagine nanosensors embedded throughout a spacecraft or space habitat, constantly scanning for signs of solar activity. These sensors could detect fluctuations in radiation levels, magnetic fields, and particle emissions, providing real-time data on potential space weather events. With this information, mission control could issue timely warnings, allowing astronauts to take shelter or adjust their course to avoid hazardous conditions. Beyond detection, nanotechnology could enhance our ability to predict these events. By analyzing patterns in solar activity, nanosensors could help scientists develop more accurate forecasting models. This would be particularly valuable for long-term missions, where exposure to space weather could have cumulative effects on both human health and equipment durability. Another exciting application lies in the integration of nanosensors with protective systems. For instance, sensors could trigger the deployment of radiation shields or activate emergency protocols when dangerous levels of cosmic radiation are detected. This proactive approach would minimize risks and ensure the safety of both crew and critical systems. Moreover, these sensors could be deployed in networks across space, forming a web of monitoring stations that track solar activity from multiple vantage points. This would provide a comprehensive picture of space weather, enabling more precise predictions and better preparation for future missions. By leveraging nanotechnology in this way, we could turn the unpredictable nature of space weather into a manageable challenge. With early warnings, advanced predictions, and automated protective measures, nanosensors could play a vital role in ensuring the safety and success of space exploration. Now, let's explore how nanotechnology could open new frontiers in space-based manufacturing, transforming how we build and innovate beyond Earth. Shifting our focus to the realm of innovation, let's consider how nanotechnology could redefine manufacturing beyond Earth. Picture this: in the unique environment of microgravity, traditional manufacturing processes face significant challenges, but nanomaterials could offer groundbreaking solutions. By leveraging the properties of these tiny structures, we could unlock entirely new possibilities for creating advanced materials and products in space. One of the most exciting prospects is the ability to manufacture materials with unparalleled precision. In microgravity, nanoparticles can be manipulated in ways that are impossible on Earth, allowing for the creation of stronger, lighter, and more durable materials. Imagine spacecraft components or habitat structures built with nanomaterials that are not only more efficient, but also tailored to withstand the harsh conditions of space. Nanotechnology could also enable the production of specialized products that are difficult or impossible to make on our home planet. For instance, certain alloys and crystals can form more uniformly in microgravity, resulting in materials with enhanced properties. This could lead to breakthroughs in fields like electronics, energy storage, and even medicine, as space-based manufacturing could produce components with higher performance and reliability. Another transformative application lies in on-demand manufacturing. Instead of transporting pre-made parts from Earth, astronauts could use nanobots and advanced 3D printing techniques to produce tools, spare parts, and even entire modules as needed. This would significantly reduce the cost and complexity of space missions, making long-term exploration and colonization more feasible. Furthermore, space-based manufacturing could pave the way for sustainable practices. Nanomaterials could be used to recycle and repurpose waste products, ensuring that resources are used efficiently and minimizing the environmental impact of human activities in space. This aligns with the broader goal of creating self-sustaining colonies that can thrive independently of Earth. By harnessing nanotechnology in space-based manufacturing, we could unlock a new era of innovation and efficiency. From advanced materials to on-demand production and sustainable practices, the possibilities are as vast as the cosmos itself. Next, let's delve into how nanotechnology might uncover the mysteries of ancient extraterrestrial civilizations, opening a window into the past of our universe. Turning our attention to the mysteries of the past, let's explore how nanotechnology could revolutionize space archaeology. Imagine a future where nanobots are deployed to distant planets or moons, meticulously scanning the surface for traces of ancient extraterrestrial civilizations. These tiny explorers could uncover artifacts and structures buried beneath layers of dust or rock, revealing insights into societies that may have thrived long before humans even existed. One of the most compelling applications is the use of nanosensors to detect subtle changes in the environment. These sensors could identify chemical residues, microscopic imprints, or even faint energy signatures left behind by advanced alien technologies. By analyzing these traces, scientists could piece together the history and capabilities of civilizations that once inhabited these distant worlds. Nanotechnology could also enable the preservation and analysis of delicate artifacts. Traditional excavation methods risk damaging fragile materials, but nanobots could gently extract and examine them at a microscopic level. This would allow researchers to study the composition, construction techniques, and even the cultural significance of these artifacts without compromising their integrity. Another fascinating possibility is the use of nanobots to reconstruct ancient structures. By mapping the layout and materials of ruins, these tiny machines could create detailed digital models or even physical replicas, offering a glimpse into the architecture and urban planning of alien societies. This could provide valuable clues about their way of life, social organization, and technological achievements. Moreover, nanotechnology could help us understand the broader context of these discoveries. By analyzing the geological and atmospheric conditions of the time, nanosensors could reveal how these civilizations interacted with their environment and what factors may have led to their rise or decline. The implications of this technology for space archaeology are profound. It could transform our understanding of the universe's history, shedding light on the existence and nature of life beyond Earth. As we continue to explore the cosmos, nanotechnology may be the key to unlocking the secrets of ancient alien civilizations. Next, let's examine how nanotechnology could shape the tools and methods used to educate the next generation of space explorers. Now, let's shift our focus to the future of space education and how nanotechnology could play a pivotal role in shaping it. Education is the foundation of any successful space exploration mission, and nanotechnology has the potential to transform how we train and prepare the next generation of astronauts, scientists, and engineers. By creating interactive and immersive learning tools, nanotechnology could make space education more engaging, effective, and accessible. One of the most exciting possibilities is the development of nanosensor-equipped training modules. These modules could simulate real-world space environments with incredible accuracy, allowing trainees to experience the challenges of microgravity, extreme temperatures, and cosmic radiation in a safe and controlled setting. By providing hands-on experience, these tools could help students develop the skills and resilience needed for actual space missions. Another groundbreaking application is the use of nanomaterials to create dynamic educational displays. Imagine holographic projections that can bring complex concepts like orbital mechanics or spacecraft design to life in 3 dimensions. These displays could adapt to the learner's pace, offering personalized explanations and interactive elements to deepen understanding. Nanotechnology could also revolutionize virtual reality systems used in space education. By integrating nanosensors into VR headsets and gloves, trainees could feel tactile feedback and interact with virtual objects as if they were real. This level of immersion would make training sessions more realistic and effective, preparing students for the physical and mental demands of space exploration. Furthermore, nanotechnology could enhance collaborative learning by enabling real-time data sharing and analysis. Nanosensors embedded in educational tools could monitor a student's progress and provide instant feedback while also connecting them with peers and mentors around the world. This collaborative approach would foster a global community of space enthusiasts, encouraging innovation and knowledge exchange. The potential of nanotechnology in space education is immense. It could not only make learning more engaging and effective, but also inspire a new generation of explorers to push the boundaries of what's possible. As we look ahead, these tools could be the key to unlocking the full potential of humanity's journey into the cosmos. Next, let's explore how nanotechnology could pave the way for sustainable space colonization. Now, let's envision the ultimate frontier: space colonization, and how nanotechnology could be the cornerstone of this monumental endeavor. Establishing human colonies in space is no small feat, but with the power of nanotechnology, it becomes a tangible reality. From constructing habitats to ensuring sustainability, nanotechnology could address the critical challenges of living beyond Earth. One of the most vital roles nanotechnology could play is in the creation of durable and lightweight materials for space habitats. Imagine habitats built from nanomaterials that are not only resistant to extreme temperatures and radiation, but also capable of self-repairing from micrometeoroid impacts. These structures would provide a safe and reliable environment for colonists, ensuring their long-term survival in the harsh conditions of space. Another key application is in resource management. Nanotechnology could revolutionize how we extract, process, and recycle essential resources like water, oxygen, and minerals. Nanobots could mine asteroids or lunar surfaces for valuable materials, while advanced filtration systems could purify and reuse water efficiently. This self-sustaining approach would reduce our dependence on Earth and make space colonies more autonomous. Energy is another critical factor, and nanotechnology could optimize its generation and storage. Nanomaterials could enhance the efficiency of solar panels, providing abundant energy for colonies even in low-light conditions. Additionally, nanotechnology could improve energy storage solutions, ensuring a consistent power supply for life support systems and other essential operations. Health and well-being would also benefit from nanotechnology. Nanosensors could monitor the health of colonists in real time, detecting potential issues before they become serious. Targeted drug delivery systems could provide precise medical treatments, ensuring the crew remains healthy and productive. Finally, nanotechnology could enable large-scale manufacturing in space. Instead of transporting materials from Earth, nanobots could assemble tools, equipment, and even entire structures on site. This would significantly reduce the cost and complexity of space colonization, making it more feasible and scalable. In summary, nanotechnology holds the key to not only establishing human colonies in space, but also ensuring their long-term sustainability. By addressing the challenges of habitat construction, resource management, energy, health, and manufacturing, nanotechnology could make the dream of space colonization a reality. Imagine a future where humanity thrives among the stars, powered by the incredible potential of nanotechnology. As we bring our journey through these 30 predictions to a close, it's clear that nanotechnology has the potential to redefine space exploration as we know it. From self-healing spacecraft materials to advanced life support systems, from terraforming distant worlds to cleaning up space debris, the possibilities are as vast as the cosmos itself. Each prediction we've explored today paints a picture of a future where humanity's reach extends far beyond Earth, powered by the incredible capabilities of nanotechnology. Imagine a world where nanobots repair spacecraft in orbit, where spacesuits offer unparalleled protection, and where entire colonies thrive on resources harvested from asteroids. Picture a future where radiation shielding makes deep space travel safe, where nanotechnology enables us to grow food in the void of space, and where habitats on distant planets are built by tiny, tireless machines. These aren't just dreams, they are the building blocks of a future that nanotechnology could help us achieve. As we reflect on these predictions, it's hard not to feel a sense of wonder and excitement. Which of these ideas resonates with you the most? Is it the prospect of space mining, the potential for terraforming, or the promise of advanced medical care for astronauts? Let us know in the comments below. We'd love to hear which prediction sparks your imagination and why. If you've enjoyed exploring the future of space exploration through the lens of nanotechnology, don't forget to subscribe and hit the notification bell. We're constantly diving into futuristic technologies and the possibilities they hold, and we'd love for you to join us on this journey. Together, let's keep imagining the incredible future that awaits us among the stars. Until next time, keep dreaming big, because the impossible might just be closer than we think.